Welcome to the deep dive. Today, we're pulling back the curtain on something really fundamental. Almost completely invisible, actually, but it powers basically our entire digital existence. We are talking about electronic connectors. Yeah, those little unsung heroes tucked away inside everything, right? Your phone, your car, and EV. They're silently making sure our connected world actually connects. And our mission, really, in this deep dive, is to give you a shortcut, a way to understand this surprisingly critical market. It's evolving so fast. We're going to unpack the key insights from a pretty recent market analysis, cognitive market research, updated just last month. Because honestly, what happens with these tiny bits has huge implications for, the whole tech landscape.
That's absolutely right. Our goal here is to sort of peel back the layers, show you the sheer scale of this electronic connector market. We want to reveal the forces driving its growth, maybe some surprising hurdles it's facing, and definitely the exciting innovations that are just around the corner. The idea is to give you, the listener, a really comprehensive, insightful overview, but, without drowning you in data.
Okay, let's dive right in then. Why exactly are these electronic connectors so crucial? I mean, yeah, they're everywhere, but what's their fundamental role?
Well, at their core, they are the essential bridge. Simple as that, almost. They let data and power move seamlessly across countless devices, countless industries. Without them, you just don't have a reliable connection. And think about it, they're absolutely fundamental across so many different sectors. You've got consumer electronics, obviously, but also automotive systems, industrial automation, telecoms, aerospace, even critical healthcare applications. And as tech marches on, the demand isn't just for more connectors, it's for connectors that are, faster, much smaller, and way, way more reliable.
And the market size, I mean, we're talking big numbers for something most people never even see. The global market was estimated around what, USD 79,581.6 million in 2024.
Right.
That's nearly $80 billion. It's not just a big number, is it? It really represents this kind of hidden dependency. Every single smart device, every EV, every little IoT sensor, it all relies on these tiny bridges. So the insight here, maybe, is that these invisible bits are actually fundamental enabler, or I guess a potential bottleneck for all future tech innovation. If connectors can't keep up, well, our digital world can't either.
That's a fantastic way to put it, because what's really fascinating is seeing how those numbers tie directly to the big drivers. Things like the super fast expansion of 5G networks, right?
Yeah.
Or the huge shift to electrification in cars and just the explosion of IoT devices everywhere. It's
Well,
not just about more devices, it's the kind of devices and what we're asking them to do. And that demand pushes innovation, like high-density connectors, high-speed ones, connectors with much better signal integrity. For a
right.
specific example, look at TE connectivity. Back in March 2023, they brought out new high-power connectors just for EV charging stations. That innovation meant faster, more efficient charging, directly supporting the whole EV revolution. Pretty cool.
Yeah, that's a great example. And it's also really telling how dominant these electronic connectors are in the bigger interconnect market picture. In 2024, they accounted for, what, about 55% of the total market? And that's projected to climb even higher, maybe 58% by 2025. That's not just a big slice, that's the main course. Just to compare, traditional soldered connections were maybe 30% and hybrid solutions the other 15%. So yeah, connectors are definitely leading the charge.
They really are.
So those current numbers are pretty eye-opening. But maybe what's even more compelling is where this market is actually going. Can you walk us through the growth forecast?
Absolutely. And yeah, this isn't some short sprint. It's more like a sustained climb. The forecast sees the market hitting approximately USD 117,578.3 million by the end of 2032. And that comes with a pretty robust compound annual growth rate, a CAGR of 5.0%. That's, solid, consistent growth for almost a decade ahead.
5% CAGR? Yeah, that's strong. And within that growth, the regional picture from 2024 is interesting too. North America had the biggest share, around 35%. Europe followed at 30%, and then the Asia-Pacific region, currently at 25%, but it's pegged as the fastest growing rate, expected to hit maybe 28% by 2025, with a really impressive 6.2% CAGR. That regional dynamic definitely jumps out.
It really does. And there are reasons behind that. North America's dominance, that's fueled by big investments in high-speed data infrastructure, plus strong demand from aerospace, defense, and of course, EV adoption. Europe's growth is similar in some ways, lots of industrial automation. And again, the automotive sector's needs are huge and changing fast. But you're absolutely right about Asia Pacific. That's where the explosive growth is happening. You've got countries like China, Japan, South Korea really leading the charge. It's fueled by, well, everything. Rapid advances in consumer electronics, really aggressive 5G rollouts, and huge investments in next-gen semiconductor tech. It's kind of a perfect storm for connector demand.
That totally makes sense, especially when you think about the sheer scale of manufacturing and R&D over there.
Yeah.
So if we connect this to the bigger picture, it sounds like a really competitive landscape.
Mm.
Who are the major players, the sort of titans in this space,
Yeah.
and how are they staying on top?
Yeah, it's definitely dominated by a few key players, but that doesn't mean it isn't fiercely competitive. You have TE Connectivity leading the pack with about 14% market share in 2024. Then Amphenol Corporation close behind at 12%, and Molex, which is part of Koch Industries, at around 10%. These companies, they aren't just selling parts. They're driving the innovation through massive R&D investments. They're focused on boosting performance, pushing miniaturization further, supporting that ever-growing demand for high-speed data.
Right.
And we're also seeing a lot of M&A activity, mergers, acquisitions, strategic partnerships. It's all about expanding their product lines and strengthening their global footprint. Competition's only expected to get more intense by 2025 as everyone tries to grab a bigger piece of that growing pie.
Okay, so it's a picture of really impressive growth, strong players.
Mm-hmm.
But like any growth story, there got to be some caveats, right? Some potential speed bumps, maybe even roadblocks ahead,
Yeah.
despite the strong trajectory.
Oh, absolutely. There are definitely challenges. One of the big ones, and maybe a bit surprising, is the environmental impact. Specifically, e-waste. We tend to think about phones and laptops when we talk e-waste, but the sheer volume of obsolete connectors, it adds up significantly. It's almost like a silent e-waste crisis. Millions of tiny, often hard-to-recycle components contributing globally. Because technology moves so fast, older connectors become obsolete pretty quickly, creating more and more waste. So there's a real push now for more sustainable manufacturing, for recyclable materials. You see regulations like the EU's ROHS directive pushing for greener connectors, but balancing compliance with cost efficiency, that's still a major hurdle for manufacturers.
That's a really powerful point, the hidden e-waste aspect. And it's not just environmental stuff, is it? There are also those fundamental engineering challenges like signal interference or mechanical failures, especially when you're pushing into those really high-frequency applications.
That's another critical one, definitely. As devices get smaller and more packed with power, just making sure signals get through reliably in those dense environments, it becomes incredibly tough. You run into problems like EMI, electromagnetic interference, and crosstalk. That's where signals kind of bleed from one connection into another nearby one. Both of those degrade signal integrity. That stat, about 15% signal loss above 40 gigahertz. To put that in perspective, imagine trying to stream, I don't know, a 4K movie, and just 15% of the data vanishes into thin air, constant buffering, glitches. It's that kind of fundamental physics problem. Connector engineers are really battling that, especially as we look towards 6G, where like every nanosecond of signal integrity is going to matter. So fighting this means constant work on better shielding, finding improved materials. It's ongoing.
Right. And then there's the third challenge, which seems maybe the most relatable, but also crucial, just basic durability and reliability, especially in really tough environments. We've all had that charger cable just stop working, right? Or a headphone jack gets flaky. That's a connector failing on a small scale. But imagine that in, say, a factory or a plane.
Exactly. And that's absolutely critical for sectors like industrial automation, aerospace, the military, places where connectors face extreme temperatures, constant vibrations, moisture, you name it. Your standard connectors just won't cut it. They degrade over time, leading to performance issues, or worse, outright failure. Take aerospace, for instance. The reliability standards are incredibly strict because, as you said, a failure there could be catastrophic, no room for error. So addressing these durability needs means constant innovation in connector design, in the materials used, in sealing technologies to keep the bad stuff out. It's about survival in the harshest conditions.
Okay, so those are some pretty significant hurdles. But despite them, when we look ahead, it really feels like the electronic connector market is set for some truly transformative advances. Like innovation in high frequency and miniaturized solutions is really going to drive that next wave.
It absolutely is. The focus is definitely on advanced materials, cutting-edge manufacturing methods, anything to improve durability, signal integrity, overall efficiency. And what's pushing this forward critically are things like the emergence of 6G networks, the growth of AI, next-generation computing. All of these demand connectors capable of handling just unprecedented data speeds, ultra-high-frequency stuff way beyond what we typically think of today.
And we're already seeing concrete examples of this innovation happening now. Like Heraus Electric introduced a new line of millimeter wave connectors just this past January, right? January 2024. That feels like a direct answer to some of those challenges.
Yeah, those new millimeter wave connectors are incredibly significant. They're specifically designed for the kind of high-speed data needed in next-gen communication and radar. Pushing frequencies past 90 gigahertz, that's not just a bigger number. It's like entering a whole new realm of physics. At those frequencies, even the tiniest imperfection in a connector acts like a huge roadblock for the signal. So getting superior signal integrity at these millimeter wave frequencies, it's like building a super smooth, whisper-thin highway for data where even a microscopic bump could cause a pileup. And that directly serves the needs of future 6G networks, advanced automotive radar, satellite communications, all that cutting-edge stuff.
So it's about pushing those physical limits. What other big trends are emerging that might really redefine what connectors can actually do?
Yeah. Well, another really fascinating trend is the move towards what you might call smart and modular connectors. These aren't just passive pieces anymore. Think connectors embedded with tiny sensors, with IoT capabilities built right in. This allows them to do things like real-time diagnostics, even predictive maintenance. Imagine a connector basically telling you, hey, I'm showing signs of wear, might fail soon, before it actually breaks down. They can provide really valuable data on connectivity performance, helping prevent those costly failures, significantly cutting downtime. We definitely expect to see faster adoption of these kinds of intelligent connectors, especially in industries where reliability is just paramount. Industrial automation, healthcare, automotive again. It's potentially a real game changer for system uptime.
Wow. So we've really covered a lot of ground here, taking a deep dive into this dynamic electronic connector market.
Yeah.
We've seen the impressive growth, highlighted some critical challenges, everything from e-waste to signal integrity, and looked at that exciting wave of innovation driving the future.
Indeed. And maybe a final thought to consider is how these components, these increasingly powerful yet mostly invisible parts, they're not just connecting devices anymore. They are fundamentally the enablers of this ever more interconnected, intelligent, and frankly autonomous world we're building. Which leads to an interesting question, doesn't it? As technology gets more seamless, more integrated into every part of our lives, how much more critical does the silent foundational role of these connectors actually become?
Something definitely worth pondering next time you plug something in. We hope you continue exploring the often hidden complexities of our incredibly interconnected world.